Hey all, welcome again. And this time around, we are going to talk about the hiring of embedded roles or embedded roles that are now available. Uh, or rather, we have seen these roles pop up a lot more these days, which is cloud companies hiring for embedded roles, which is a little interesting. And so we're going to then talk about like the recent trends in the roles and hiring around the embedded systems. And recently, Rajat had been to, interestingly, Meta's networking event, and this was like specifically for embedded and software and hardware engineers. So yeah, go ahead, Rajat, take it over.
Yeah. Uh, so just to have a highlight, Meta organized a networking event somewhere. I think it was last week,
Mm-hmm.
and I'm really not sure how they figure out whom to call, but there was some random invitations thrown out,
Uh-huh.
and people have to RSVP to it. And I had one, and so I decided to go, and I was curious because the title was very curious. It's an ASIC networking event,
Mm-hmm.
and
Mm-hmm.
so I decided to go. So I didn't even know they had an office. I searched Google Maps, and I was still not able to find a Meta office over there, and I was not sure where it's going to happen. So they did arrange a cab pickup and drops
I
for
heard
us
it
for the
was a
event.
limo.
Not limo, but not desire as well. So desire as well.
So let me get this right. Like, first off, even I wasn't aware that Meta actually had an office in Bangalore. I
Yeah,
mean, forget office in Bangalore. I didn't even know they had like an office in India, but apparently they do, and they have an office in Bangalore, and they are hiring embedded engineers now for the
yeah,
ASIC related roles.
yes. Uh, yeah, so so they do have an office. It's in Gurgaon, but
I
that's
see.
more of a sales and software office.
Hmm.
With Bangalore, uh, the essence. When we went there were a couple of guys who have traveled from the US. Couple of the Meta employees that are there in Bangalore, ASIC department. They were there. The whole essence of like what I got from the event was Meta announcing that they are going to hire a lot of people in the Bangalore office, and they are
Hmm.
going to start a Silicon Design Center in Bangalore, and they just wanted to come and spread the words among people. And
Right.
looking at the trend, it's not only Meta that did it. I remember Microsoft last year when they started hiring Silicon, they did the same kind of event. Google also does some kind similar kind of event. Some of there were very interesting numbers that were presented over there,
Hmm.
and the general trend that I have been seeing is the boom of AI, where
Hmm.
everybody wants to explore what they can do with Gen AI, and all these cloud companies are facing a shortage of the
Hmm.
AI infra.
Hmm.
Nvidia just can't manufacture more GPUs for these
Right.
guys to put
Right.
in.
Right.
So they were very interesting numbers, and surprisingly, and I was not aware. I know Google used to do TPU very long. Google started realized that this may be a problem in the future, and they started doing TPU way
They're
early
not.
Hmm.
Yeah. Yeah.
in 2015. Apparently, Meta started doing this in 2018.
Ah. Right.
So
Right.
they have
Interesting.
already published two generations of their AI accelerator. Uh,
Hmm.
they are not a cloud company. They use their own data centers for their own use cases.
Right.
So,
And
but
mhm.
they started their own development of own AI accelerator as well as video encoders decoders to fast up
Mhm.
the uh, to minimize the running costs of the
Latency.
data centers.
Right. Right. And I think everyone's also trying to push AI computation to the edge.
Yeah,
The more inference happens at the edge, the less the cloud providers have to suffer in terms of like the bandwidth and server infrastructure, so on and so forth. Well, this is interesting. I think we should also talk about why would the man companies now, like cloud is one, AI is one, but in general, like for example, Microsoft came up with the Copilot Plus PCs, right? And they are like the X Elite SoC based. An interesting question to ask, I suppose, is who was doing the port of the Windows operating system for
it's
the ARM
collaboration.
SoC, right? So, and typically, at the heart of it all, at like that bottom layer would be embedded engineers doing that, right? So it kind of, in my head, it makes sense that, at least the hiring in that department for embedded roles would go up. And I suppose, again, going back to the whole cloud story, that each company now is making their own cloud CPU also,
Hmm.
cloud CPU or cloud infrastructure or machine. Like I suppose Microsoft had announced their own, ARM-based server. Then recently, Google had announced ARM-based servers, and then I suppose Amazon is already on like the
Amazon
ARM
has been
server.
doing it for long.
Right, right.
So I
Hmm.
think so. They were so these were one of the things that was presented at Meta, like why Meta should do its own hardware.
Mm-hmm.
So I may not be exactly right on the numbers that they presented. It's very clouded, but what they showcased is that Meta had around 4,000 GPUs when they trade Llama 1, Llama
Mm-hmm.
1 or Llama 2. And when
Okay.
they went from Llama 2 to Llama 3, Meta tripled their AI, their GPU presence, and they bumped up from somewhere around 4,000 to 16,000 GPUs.
Hmm.
Wow.
And when they look at the internal models and internal graphs that the internal AI software and model teams are projecting to train the next model of next generations of Llama, they are gonna need some lakhs of GPUs, and Nvidia
Mm.
can't. None of the GPU companies can simply manufacture
Provide that.
those.
Yeah.
Hmm.
They
Okay.
can't manufacture at this scale GPUs.
What's stopping them, Rajat? Do you know?
But like the the TCM, like the uh,
TSMC. Yeah.
TSMC is the only company which does these things, right? And
Well,
then now
there's
Intel being the one,
there is
another one, right?
Samsung, TSMC,
Hmm.
and Intel. Now it
Right.
depends
So,
what node and
Right.
hmm.
what
so,
manufacturing capabilities you
so,
need.
so these companies can still, develop or manufacture these GPUs, right? Why Meta is going,
I
you
No,
know,
suppose
no.
it's
So they
less.
are no, no. So here's the thing. For Nvidia to manufacture these much GPUs, Nvidia has to project that how many GPUs will be needed by each of these companies in the future.
hmm,
Nvidia just can't, manufacture lakhs of GPUs and be like, okay,
Yeah.
I know
Mm.
Google, Microsoft, and Meta are gonna take this in next 2 years. So they
Mm.
look at they each of these companies look at a model or the trending model of their sales, and based on that they predict how many wafers they need for next couple of quarters.
And
So
also,
the problem
mm,
is
yeah.
that the companies that want these wafers is not Nvidia. And so Meta and Google are on a good position to predict what they need in the future, how much AI capacity they need over the future. And this was exactly the motivation behind why Google did TPU in the past, right?
Mm.
Because they can predict what the future models are coming and how they can influence the architecture to optimize it out. And
hmm,
that's exactly where Meta and Microsoft is going, because they don't want to rely on a single company to define what their future growth can look like.
Yeah. And I suppose, just adding in here, at scale, it makes sense that you manufacture your own thing, because then
hmm.
you're like paying for that, or you're paying the margin to the other company if you buy like bulk from the
Hmm.
Yeah, there is
Nvidia being
also a
that.
cost factor
Right.
coming in
And
picture, right?
given that Nvidia has become like the, kind of like the shovel seller, it gets that pseudo monopoly on, cranking up the price also.
Hmm.
So
So
that's that.
they did mention that price is actually not the problem.
I see. Okay.
Even if
Okay.
Meta has the money to, and they are like, okay, Nvidia give us 1 lakh GPUs in next 1 month. Nvidia cannot do
Nvidia
that.
won't be able to
Nvidia won't
supply.
be able to do that.
Hmm.
So
Hmm.
price is not the limiting factor over here. The factor is that predicting the scalability,
I
predicting
see.
the workloads, and that
But then,
is
like,
much better done by all these software companies
But then
than Nvidia.
if they can
like,
do that, why don't they commit to, orders with
right?
Nvidia? Why go to the
Yeah,
fab straight?
Oh,
yeah.
because the typical silicon cycle is long, and the software
I see.
industry is moving way faster than. So you want the silicon architecture to be, because Nvidia won't tune down their architecture specifically for Meta.
That is
Meta
true.
Hmm.
wants to do
Yeah,
AI
that
for
is.
video. Nvidia is not gonna scale it down only for Meta and do a chip only for Meta.
That is true. Yeah.
Hmm.
So all these companies ultimately wants to do their own hardware because they want to fine tune. their architecture to the workloads they have. And there was an instance in the Meta networking event as well where they gave an example. So looking at their architecture, one of the person asked, your memory architecture looks very sparse.
Hmm.
Why is it? And they are like, we have to do that. We did that to satisfy one workload, because one workload has
I
a
see.
requirement. It is
Understood.
better if you have a memory architecture like that. That
Hmm.
workload will perform better. So they can fine tune their hardware as they
Right.
want.
But
And
Nvidia
they
cannot
they
do that,
don't
I
have
think.
to. You don't have to stick, because for example, Google has a lot of AI use cases, right? Search, video, etc. Meta has video, etc. as their, so they can look at what exactly they want to accelerate in that AI models, and
Right.
they can find
Right.
their architecture for that.
Yeah,
Right.
that is true.
So
Very true.
Nvidia, it's exactly like Nvidia is a general purpose machine. You want to do everything, they can do it. And today they are the undisputed king over there for the
Yeah.
training, etc.
Yeah.
But each of the what each of these companies are realizing that first the operating costs are going to be high, and second they won't be able to scale it much.
Right.
Mm,
This kind of reminds me of one interesting theory, which is slowly for AI, the differentiating factor would be how fast you can compute and how much less power can you spend.
mm,
And this, I suppose, is enough for, down the lane, every software company to consider making their own silicon, because the thermal room that you get can only happen if you have your own what do you say, your own ASIC.
Yeah.
Otherwise, if you're limited by somebody else's hardware, no matter how
Hmm.
good of a model you have,
mm.
the computation becomes the bottleneck.
And plus, I think Piyush, to add to that, hardware is the only thing which will set everyone apart because
Yes,
everything on
that
the
will be
software
there.
stack is open source. Everyone
Yeah.
is gonna
Mm.
use the same damn
Yeah.
thing.
Yeah.
So you
Yeah,
need
get
some advantage, competitive advantage that's gonna come via hardware.
Yeah.
Yeah.
right.
For
Can
example, the
someone
TensorFlow
comment
library
on the
is
power?
common, irrespective whether it is GPU or
Yeah.
TPU. What
I,
sets apart GPU, Google Cloud performing well on TPU versus GPU is the TPU.
Yeah.
right. By the way, go ahead, Dave. You had
Yeah,
a
so
question.
can someone comment on the power, like what power consumptions are
Oh, okay. I
for
can. I can.
Nvidia?
Well, R is a difficult. Like I don't think I have exact answer to that. I can give a proxy model of why
Mm,
something like a neural engine might be like more efficient than, let's say, GPU. So the whole point is that we are doing matrix multiplication, matrix
mm,
operations essentially. Turns out that GPUs have lot of tiny units to do the mac operations, multiply, accumulate, right? Okay, now the thing is, for AI related cases, we are all right working with like an 8-bit integer
Hmm.
compared to, let's say, the 32-bit integer that Nvidia GPUs can process. So all of a sudden, if you design a hardware that can, which is like a lossy hardware, if 9
Hmm.
becomes an 8, it's all right in case of like neural networks.
Hmm.
uh, s- so what will now happen is your multiply unit, which in, let's say, a GPU, not Nvidia's, any GPU,
Hmm.
if it is designed to do like 32-bit multiplication,
Uh, Here
that
also, Piyush, it was floats. So you are saving a
oh
lot more
yes,
on the circuitry as well.
yes, yes. So this is not just like
Hmm.
multiply integers. This is like multiply floating values. Let's say 32-bit wide or 32-bit encoded. So the hardware for this is way complex than a lossy hardware, wherein you are like, okay, if my 9.38 becomes 9.39, I am all right.
Hmm.
Or even if
mm,
it becomes like 7.13, I'm like pretty okay with
Hmm.
it, because neural nets do that. They lose information,
right.
and
Hmm.
that entropy kind of makes the
Hmm.
model, I suppose, uh, more reliable, more accurate. I don't know,
Robust.
more robust maybe. Yeah.
Mm,
So because of
Hmm.
that, like you can perform. Let's say, I'm just throwing some numbers here, right?
Hmm.
If, let's say, doing the computation on Nvidia GPU, or not just Nvidia, any GPU costed like 4, then because you're doing 8-bit operations, we might have like 4x the computation,
Yeah,
just because.
4x the computation, 4x the memory saving, 4x the the reduction in latency and all of that. It's
Yeah.
crazy.
mm,
And then if you're kind of thinking about workloads that are going to, for example, let's say, Meta's Oculus, There's like
Hmm.
a lot of AI that, let's say, the needs to be done on the camera image that, or
Hmm.
camera feed that's coming in. So clearly, if you're battery powered, then a GPU gives you like a 4x power hit compared to a TPU, right? So that's like a layman's way of understanding, how much
Mm.
power saving you can
Hmm.
have. Yeah.
And I think the power consumption is the biggest, cost for data centers, right? Like,
Yeah.
and
Pow-
also
uh,
the
uh,
heating.
exactly.
Hmm.
So it's
Yeah.
both
Double
it's
way.
power as well as heating, because you are consuming power to cool down your data
Yeah,
centers,
yeah.
So yeah,
and
Right.
also you are consuming power to run those data
Generate.
centers.
Yeah, yeah.
it's
Man.
like oh yeah, coming to think of that, it's not just like the chip heating up.
Yeah.
It's
And
like spending
radiation has a
electricity to
huge
cool it down.
impact on environment as well. Like
Yeah.
I was reading
Mm.
some reports where we are generating like CO2 emissions are through the roof just because
Of
So
the
the way
data
it's
yeah,
centers.
happening.
so that's where a lot of companies have been trying to reduce down these costs. So, for example, I know Microsoft in the past tried to put underwater data
Yeah.
centers. They
Mm.
recently closed it.
Yeah.
Uh, at least that's what I read, that
Okay.
that
Okay.
project has been closed. But a lot of companies have been doing that, like using natural cold water for
Mm-hmm.
better thermals,
Mm.
using solar to power the data centers.
Hmm.
True. Well, this brings me to an interesting conversation, maybe. Yeah. Okay. So the power dissipation of an ARM CPU compared to an Intel CPU. So I suppose like the architecture also plays a role in
Hmm.
terms of how much power you burn.
Oh, actually, there was a lot of talk from
Mhm.
Intel in this Computex,
Uh-huh. Uh-huh.
and they came around and said, it's not actually true.
I
And
see. Okay. Okay.
they announced a Lunar Lake, and there was a lot of hype that Pat created around Lunar Lake. That
Mm.
And he actually started with saying that a lot of people said x86 is dead, and I would
But it's
like to
not.
disagree with them, and I would like to show them in the next quarter what we can do with x86.
X86 goes risk, I suppose. Then I don't.
No, so they are changing x86 architecture. The way Intel chips were, the all the micro architecture of the Intel chips are
I see
changing
that
too
is
much.
changing. Okay. Okay. So it's like an overhaul at a
Yeah, so
design level.
ISA is
Hmm.
just a
True.
abstraction layer
True.
between hardware and it's right. So
True.
it's all about how efficiently you decode it, and
Hmm.
it's
Hmm.
just a different approach that people take. That is risk versus risk
True.
processors.
Well, I suppose my comment was coming from the standpoint that given the hype around the Copilot plus PCs now,
Yeah,
Hmm.
and the fact that, and even the ARM based, Macs, which are like the M1 through M4 now. So, like these PC makers and the Mac makers have been able to kind of get rid of the fan. And so when I think about an Intel CPU, the fan is the only thing I remember. And then we are talking about data centers and God knows,
yeah,
if Intel CPUs are like scattered there like salt, then that's that.
yeah.
Talking about the heat dissipation and the power consumption, like the cloud providers have also been committing to going carbon neutral.
Mm.
Was this like a reason also, like in terms of they going carbon neutral because the data centers burn too much
Yeah,
power and
so it's actually both,
cost
and it's
emissions?
actually dollar per performance, as well as the carbon neutrality target that they have. So carbon neutrality in a lot of ways is like we are gonna offset whatever we are
Hmm.
releasing. It
Mhm.
it simply doesn't mean that we will stop
It may
using
come
fossil
from
fuels.
some other
Exactly.
totally
So
different.
it's
Right.
like we are burning coal, but we will set up a solar plant that can help people reduce their coal consumption.
Hmm.
Mm.
Right. Right.
So it's an operating cost, because the thing is, if you produce less carbon, you have to offset less carbon neutral, spend less money over there.
Yeah.
Plus, the monthly bill of running the data center also goes down in terms of electricity
Hmm.
and
Mm.
heat.
Understood.
Mm.
Understood. Fair.
And
Okay.
I
So.
was reading
Mhm.
statistics that like just to do, like, if you want to fetch an info, let's say from a chat gpt, uh, right, and if you fetch the same info from a traditional google search, the amount of power consumed in the chat gpt is like 100 times
More.
higher. Yeah,
Yeah,
it's like
yeah.
orders
Mm.
of magnitudes higher.
I read a bit less aggressive number, but it was still aggressive.
Hmm.
I what I read was, and again, I would
Hmm.
like, if these big cloud companies can someday publish these numbers.
Hmm.
But what I read is that it's 17 times more costlier to do chat GPT
Query.
search
Query.
than to do a traditional
Google
query.
search. Yeah. And I think, that is one of the reasons why they want to push the computation to the edge. If all of that inference can happen on the user's, let's say, device, phone or laptop, it's a lot less costly for the cloud providers.
Right.
Uh, but it's interesting how they turn that into marketing as well. It's like, hey,
Mm.
this will be evaluated on your device, more
Privacy.
secure,
More, yeah, it's
privacy.
all.
Yes, we'll kind of take snapshot of your entire screen every 1 second, but it's okay.
And that's what computer engineers are famous. Like, we all are famous for that, right? It's not a bug; it's a feature.
It's a
Yeah,
feature. Yeah, it's
it's
a feature. Cool. So
So
maybe go back. Oh, sorry.
so
Go ahead.
having the TPUs, right? The Google has TPU. So does then Gemini takes like consumes less power as compared to ChatGPT?
no
This
idea.
is,
No idea.
yes,
No idea.
exactly.
Okay.
No idea because
None of even all of these cloud companies announce that they have MAIA, TPU, MTIA, but none of them
yeah,
publish these numbers.
yeah,
Yeah.
we don't know.
We don't know.
I'm not sure
So
even if we
one,
knew.
so one of
We'd
the
revise.
interesting questions I asked from their so
Hmm.
one of the guys from the architecture team was there,
Mhm.
and I think he said that so there is a forum called Hot Chips.
Sorry,
Ah,
what?
Uh,
What?
yes, yes, hot chips.
so he said that they are gonna present the same the he's gonna be there on Hot Chips talking about Meta Accelerator. I still have to find that video whether he has gone there or not. Uh,
It was
but
just a few weeks that you had a talk with him, right? So
so
unlikely that the video is up.
yeah,
Right.
exactly. So I talked to him, and so they presented numbers how well their MTIA performed when compared to traditional Nvidia H100 or others.
What is MTI?
MTI is Meta Training and Inference Accelerator,
I see. Okay.
and they compared with the Nvidia, AMD, and multiple industry these data center centric GPUs like H100, MX300,
Hmm.
etc. And they showed the numbers, and the numbers obviously the numbers are amazing. They are like 2x, 3x performance per dollar,
Hmm.
Hmm.
and a performance per dollar. Then there were numbers for performance per watt. And I did like when we were having the networking event, and I got some time to talk to him. I asked him, I saw all those numbers, but have you ever do you have numbers where you compared it with Google's TPU?
Hmm.
So he
And
did a laugh, and he said that these are confidential, and he doesn't want to talk
okay.
about any of that.
Fair, fair, fair. Well, I think eventually, that comparison will be out.
Oh, there are already
Eventually.
comparisons out. So they are ML where we all of these companies push their numbers.
Hmm.
Uh, but I don't think that's around performance per watt. But yes, it's there. And
Hmm.
similarly, I think Pat was there in the Computex, and he announced Intel Gaudi 3, and he's like, it is 3 times performance per dollar than Nvidia.
Wow. Exciting times. Exciting
So
times.
all these companies are pushing towards AI, AI, AI.
I'm very happy
Well,
that I'm an embedded engineer.
Apple
Hmm.
is also pushing towards AI, but a different AI.
Yeah, yeah, it's Apple
It's
It's
Intelligence.
Apple
Apple
Intel.
Intelligence.
That's interesting. Well, let's maybe head towards winding up the podcast now. Can you, Rajat, also talk about the kind of roles that Meta highlighted in their event in terms of them hiring?
Yeah. So Meta highlighted that. So they want to have they are highlighted roles starting from ASIC front end design,
Hmm.
ASIC back end design, then post silicon validation, pre silicon validation, boot ROM, and firmware development. These
I
will be
see.
the 4 or 5 major roles that they will be hiring over here.
I see. And did they happen to hint at what all they are going to develop? Is it just the AI or you know?
So that they didn't say what is the roadmap, that they
Mm,
didn't share. But but overall the enthusiasm that the Meta management team presented was that there's going to be a lot of work in
hiring.
Silicon.
I see.
mm.
Very nice.
It's
Very
good news for
exciting
embedded
times.
engineers.
Yeah.
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 I see it as a win. Like, I
Yeah.
mean, everyone
So,
should.
so does like we know that Apple hires embedded engineers. Does Amazon is hiring embedded engineers in
Oh
Amazon
India?
yeah.
has been hiring for quite some time.
Yeah.
Amazon did I think they were one of the first one to to put ARM based CPUs in their server, in their
Hmm.
data centers. I
Uh,
think
Yes.
Graviton or something.
hmm.
Hmm.
And they were doing Alexa, then Fire Phone,
Yeah,
Fire TV.
yeah. I
Oh
think
yeah.
on
Mm,
these
but
fronts they have been doing, but I was wondering if on the data center they are
Yeah,
developing similar thing.
they have been doing it. I think they did it quite a long time back,
Hmm.
4 or 5 years back. I have a couple of friends who work in the Linux department for the server grade chips.
well, I don't recall which country the position was for. Was
Germany.
it for? No, 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 not this one. Not this one. The one that came my way a year and a half back. So it had to do with writing the hypervisor layer for the A class CPU. Uh,
That's where my friend is. It's German. It's
nice.
Dresden and Berlin.
Berlin. Berlin was the position. Yes,
Yeah, so
Berlin
there
was the
were two
location.
locations in Germany. It's Dresden and
Yeah.
Berlin.
So I have got pings from the not Android, Amazon recruiters around Alexa, around this position on the hypervisor development, and around their Fire TV, or that Fire Stick, essentially, right?
Price.
Fire TV. Yeah. So yeah, Amazon is also hiring. The Alexa work group works on that. The Fire TV folks work on that. I think once you go towards, or rather not towards, but a good question to ask is, yes, all of the Linux is working, yes, all of the software is working, like who is doing porting and enabling of these stacks on different machines, different boards, and all of
Hmm.
that? And the answer is hands down embedded engineers, typically kind of floated as firmware engineers, BSP, board support package engineers, then bootloader engineers, boot ROM engineers, in that format. um, if not anything, I suppose Linux kernel developers,
Driver developers.
driver developers. Yeah. So
Hmm.
that, so
But there
exciting
is
time.
also a role of application engineer,
Oh, true,
and then the design verification engineer.
true,
Yeah.
true. Well, also just to now also talk about Microsoft. So Microsoft, I got like again pings from them last year, last to last year around their Surface team. There was one more Microsoft
RAS.
Surface. Which one?
RAS.
RAS. Yes, yes. So Surface team, I think they were developing some again firmware for some um, embedded pieces on their Surface line of products. And RAS, I think, was around some new
What
CPU
is
that they are
RAS?
trying. Um,
Reliability and
Oh, accessibility
yes,
and the RAS
security.
extension, you mean?
yeah,
Hmm.
Well,
And
there
security.
was like RAS also in ARM
Yeah,
Cambridge.
that's
yeah.
Yeah,
reliability, accessibility, and security.
yeah.
That's the same one you're talking about?
No. I think it has to do with in general data centers. So RAS is a generalized concept. You can put it at a chip level, device level,
Ah, I
data
see.
center level.
Hmm.
I see. So exact like
Hmm.
part of that job we cannot decode, but okay,
Hmm.
RAS engineers, fine.
The one
I
I
see.
got for was security, the root of trust
Hmm.
I see. From Microsoft.
from Microsoft.
Nice, nice. Yeah, so I hope somewhere people now register that embedded roles are also like available at the Mang company, so to speak. And if somebody wants to chase
Hmm.
those, they can. And yeah, good times for the embedded engineers.
Yeah.
Good times ahead.
And I think
Good.
the hiring is kept on increasing, right? It's not like declining anytime soon. So
Hmm.
Yeah,
I
I
think
think
it's a good time to have the embedded skill, and then
yeah, they just help. And well,
yeah.
one way to think about that is, let's take our laptop, right? So in making a laptop happen, you've got the motherboard, the audio subsystem has a CPU. Then there is like, okay, USB port that has a CPU, network card that has a CPU. Who is programming all of these CPUs? Like firmware engineers somewhere, right? So for every product that goes out there are like many more jobs for
Hmm.
embedded engineers. And I suppose as long as new devices or new hardware is being built, at least the device driver roles are not going anywhere, right? They are just going
Mm.
to increase. Yeah,
Software has to run on something.
So one question
exactly.
that
As
since
long as software keeps evolving, silicon
Evolving,
will
yeah,
keep evolving.
yeah, to serve that need. Yes,
so
go ahead.
so we know that all big companies are hiring more and more embedded engineers, right?
Yeah,
And then given that AI boom, like there are a lot of AI startups being bought up, right?
yes. AI
So
sensors, for example,
yeah,
there are startups on
so do,
that.
do
Yeah.
you see that like similar startups will be built in this embedded domain as well, where the 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 new companies will be building let's say some chips
Oh,
for mobile.
There are
definitely.
I will say this. So there are already multiple startups that have started uh,
Mhm.
doing their own AI accelerators, and these are
Mm,
custom startups. These are startups that will provide only custom solution to a
mm,
inference or training accelerator, not a in
Mhm.
general software company. So the
Mhm.
problem is, see, silicon is a huge investment. It's
Mhm.
not a small investment. It's a huge investment. It takes years to stabilize the first silicon out,
yeah.
and startups may be hesitant in that stage, specifically if startup is very software centric and they are not very
Mhm.
established. They will still rely on, and that's where the point of cloud is, right? So that these companies don't have to think about how to accelerate their hardware. Cloud companies
Mhm.
can
Others will
provide
do
them
that.
infra to do that, and they can focus only on about creating the applications around it, like credit card management, make my trip, travel management, etc. So there might be use cases of AI over there, but they are not concerned about how much time that AI takes to run. That is cloud
Mm.
company's responsibility. All they have is
Mhm.
a requirement for the cloud company that, you know what, we want to achieve this within X amount of seconds. What kind of machine do you recommend us? What type of machine should we opt for in the cloud?
Mhm.
Well, I do expect that the IoT sector will
Yeah.
boom, and there would be like lot of startups around AI for IoT. And one of the well, AI is one thing, but one of the other reasons for a lot of startups in the silicon space is the risc-v architecture. And the reason to that is risc-v architecture enables people to invent at the hardware level. Because
Mhm.
let's say if they were going for the ARM architecture, then they have to pay a royalty, and the moment you have to pay royalty for like the units sold, you cannot reduce the price of that solution. And so there is like a definite expense, then it puts pressure on the amount of money you have to earn, so on and so forth. And also the competition is limited to that royalty price point, right? For example, let's say 50 paisa is what people have to give, let's say ARM, just as an example, right? So nobody can sell their solution less than 50 paisa. But because of risc-v architecture, now that 50 paisa floor, uh, that can be lowered arbitrarily depending on whose business model is how, and so on and so forth. So that has also enabled innovation and kind of enabled the hardware engineers to go try out like the ASIC level startups now. So that is another thing. Cool. So I think we pretty much discussed whatever we wanted to around this topic.
Yeah.
Cool. Okay. So I think we can wind up the podcast, and until next time, you know, goodbye.
Yeah.
Chalo.